Welcome to this video on the topic of indices. In this video we're going to have a look at what are indices, the notation and terminology used to describe indices, and finally we're going to have a look at how we can evaluate some numerical indices. Now firstly we ask ourselves what is an indice, and the best way to start is to lead by example. So we'll go 2 and then we'll say 2 to the power of 4. What we've got here is an expression containing indices. Now this can be broken up into two smaller components. We've got the 2 here and we've also got the 4. Now the names for both of these components are, well, the 2 we call that the base and the 4 we call that power, or we call it the exponent. Now what this expression represents is a more compressed form of the multiplication of a number of 2's. So in our case what we're saying here is this expression can be expanded out to mean 2 multiplied by 2 multiplied by 2 multiplied by 2. So effectively we've got 4 2's all multiplied together, or another way to say it is we get the base and we multiply it over itself 4 times over. Now this is the numerical representation of indices. Now because we're such mathematical geniuses, what we can do is we can expand this to include algebra as well. So suppose we have a base b raised to our exponent n. The way in which we can rewrite this is b multiplied by b multiplied by, and we'll go dot dot dot, multiplied by b, and the amount of b's that we see in here multiplied together is specified by the number represented in n. So n instances of b multiplied together. Now let's have a look at how we can evaluate some indices. Example 1, we have 3 squared. Now we can go the slow route and we can go, well, 3 squared is the same as writing 3 times 3, and 3 3's are simply 9 because we know our times tables. But what we want to be doing is when we're working with numerical indices, we always want to have our technology at hand, because technology is going to make the crunching of these numbers so much easier. So we'll go 3 squared and boom, calculator just tells us instantly. So we can go 3 squared straight to 9. Now second question, we have 2 to the power of 5. Here's where we really need to use our technology. Doing it the slow way, we're going to go 2 times 2 times 2 times 2 times 2. And then slowly evaluating it, we go 4 times 2 times 2 times 2. And then 8 times 2 times 2, 16 times 2. And then finally 32. But once again, we can use our calculator to make this much easier to do. So we can go 2 to the power of 5, so we'll put in our 2. Then we'll use this button next to the squared. There's another one. So it's an X and there's this square symbol here. We click on that and it allows us to put in whatever numerical value we want. So let's go 5. And lo and behold, it tells us the answer is 32. So by using technology, we come to the answer much easier. It's still important to understand what this notation means. So it's 5 lots of 2 all multiplied together to give us 32. But we want to be using our calculators for this because we can't memorize all of these. Now the final one, example 3 here, we've got 3 to the power of 3 times 5 to the power of 4 times 2 to the power of 3, all divided by 25. Now there's quite a lot going on here. What we need to do is we need to think back to our BEDMAS. So we've got exponents, division. Now linking these together, we've got 1, 2, 3 exponents. We've got some division. And finally we've got some multiplication. So first thing we're going to do if we try to do this computation by hand is we do our exponents first. So first one is we're going to go 3 cubed. So 3 to the power of 3, that's 27. multiplied by 5 to the power of 4, 625, multiplied by 2 to the power of 3, that's 8, and that's all divided by 25. Now, next part is we have our division and multiplication. Now, if you think back, it actually doesn't matter which you do first, division or multiplication. We just write it as BEDMAS because it makes a nice little rhyme here. So what we can do is we can simply go 27 times 625 times 8 divided by 25 all at the same time. So we'll just go that straight in the calculator. Comes out to be 5,400. Now if we wanted to do that again but the shorter way using the calculator, what we can do is 3 to the power of 3 space times 5 to the power of 4 space times 2 to the power of 3 space divided by 25. Lo and behold, we get the same answer. So what we've learned in this video is firstly what are indices. We then went over some terminology and some notation for representing indices. Then we had a look at how we could crunch or evaluate some numerical indices here.